Have you ever wondered what makes our solar system so extraordinary? From moons that spew ice volcanoes to storms that have raged for centuries, the solar system is full of astonishing phenomena that defy imagination. Did you know that some planets have magnetic fields so strong they could disrupt your compass from millions of miles away? Join us as we dive into the top 7 most unique features of our solar system, unveiling the wonders that make our celestial neighborhood one of a kind. The Great Red Spot on Jupiter. Let's talk about one of the most jaw-dropping wonders in the solar system, Jupiter's Great Red Spot. This colossal storm is so massive it could swallow Earth whole, spinning for centuries like a never-ending cosmic hurricane. More than just a storm, it's an iconic feature of Jupiter, a reddish-orange vortex that has raged for at least 400 years. With winds tearing through it at up to 430 miles per hour, it's more ferocious than the strongest hurricanes on Earth. What powers this tempest? Unlike Earth's storms, which feed on warm ocean water, the Great Red Spot draws energy from Jupiter's internal heat. This heat, generated by the planet's immense size and gravitational compression, fuels the storm like an unstoppable engine. Fascinatingly, the Great Red Spot has been shrinking over the past century. Once over 25,000 miles wide in the late 1800s, it's now about 10,000 miles across, still large enough to fit Earth but steadily diminishing. No one knows why it's shrinking, but it raises a compelling question. Could this ancient storm disappear in our lifetime? Beyond its visual grandeur, the Great Red Spot is a scientific treasure. Studying it reveals insights into gas giant atmospheres and the dynamics of extreme weather systems. It also helps scientists understand similar phenomena on distant exoplanets. Jupiter's Great Red Spot is more than a storm. It's a blend of beauty, power, and science, swirling together in one mesmerizing spectacle. Saturn's rings, a cosmic masterpiece. Saturn's rings are undoubtedly one of the most breathtaking sights in our solar system. Picture this: a planet wrapped in shimmering bands of icy particles stretching across hundreds of thousands of miles. These iconic rings make Saturn the showstopper of the night sky, often called the jewel of the solar system. What's fascinating is that these rings aren't solid. They're made up of countless chunks of ice and rock, ranging from tiny grains to massive boulders, all orbiting Saturn like cosmic dancers. What's even more astonishing is how thin these rings are. Though they span up to 175,000 miles across, they're only about 30 feet thick on average, like stretching a sheet of paper over a football field. Scientists believe the rings formed from debris of shattered moons, comets, or asteroids caught in Saturn's immense gravity. It's a stunning example of the universe turning chaos into beauty. The brightness of Saturn's rings comes from their composition, mostly water ice, which reflects sunlight brilliantly. The rings are divided into distinct sections such as the A, B, and C rings, with gaps like the Cassini division creating a mesmerizing, intricate pattern. This combination of shimmering ice and dramatic gaps makes Saturn's rings look like the universe's most elegant jewelry. Here's the bittersweet truth: Saturn's rings won't last forever. Over time, gravity pulls the particles toward the planet in a process called ring rain. While the rings are expected to disappear in tens of millions of years, we're fortunate to witness their beauty now. Saturn's rings aren't just a cosmic masterpiece, they're a fleeting one, reminding us of the ever-changing nature of the universe. They are a spectacular blend of science and art, offering a glimpse into the creativity of the cosmos. Enceladus, the moon that sprays water into space. Enceladus might seem unassuming at first glance, but this tiny moon of Saturn is one of the most remarkable places in our solar system. Just 310 miles wide, it's covered in bright white ice that reflects nearly all the sunlight it receives, making it one of the most reflective objects in space. But what truly sets Enceladus apart is its spectacular geysers, which shoot massive plumes of water vapor, ice, and organic molecules into space. These geysers erupt from cracks near the moon's south pole, known as tiger stripes. What's even more fascinating is that scientists believe the water comes from a vast subsurface ocean hidden beneath its icy crust. Despite its cold, distant location, Enceladus's ocean remains liquid due to tidal friction, heat generated by Saturn's gravitational pull and interactions with nearby moons. This makes Enceladus one of the few places in the solar system where liquid water might exist, raising the tantalizing possibility of life. The material ejected from the geysers doesn't just fall back to the moon, it also contributes to Saturn's faint E-ring. NASA's Cassini spacecraft even flew through these plumes, discovering organic molecules, the building blocks of life. This incredible finding has made Enceladus a key focus for astrobiology, as its hidden ocean could potentially harbor microbial life. Future missions are already being planned to explore Enceladus further. Scientists hope to land probes on its surface or sample its plumes directly to search for signs of life. Enceladus isn't just another icy moon, it's a beacon of possibility in our quest to find alien life. This tiny, icy world reminds us how much mystery and wonder still await in the vastness of space. Wouldn't you love to explore it? The Sun's mysterious corona. The Sun isn't just a fiery ball of gas. It's a cosmic powerhouse full of mysteries, and one of its most fascinating features is the corona. The corona is the Sun's outermost atmospheric layer, and it's not just hot, it's astonishingly hot. While the Sun's surface is around 10,000 degrees Fahrenheit, the corona reaches a staggering 1 to 3 million degrees Fahrenheit. That's millions of degrees hotter than the surface, a phenomenon scientists are still trying to understand. One of the most mesmerizing views of the corona happens during a total solar eclipse. When the moon blocks out the sun, the faint glowing halo of the corona appears, its flowing plasma creating an almost magical spectacle. But don't be fooled by its beauty. The corona is an incredibly dynamic and volatile region. It's the birthplace of solar winds, streams of charged particles that travel at up to 500 miles per second, creating auroras on Earth but also threatening satellites and power grids during intense solar storms. The mystery of why the corona is so much hotter than the sun's surface, known as the coronal heating problem, has puzzled scientists for decades. Some theories suggest bursts of energy called nanoflares, created by the sun's magnetic fields, might heat the corona. Others propose that energy waves traveling through the sun's magnetic field deposit heat into the corona. Missions like NASA's Parker Solar Probe are venturing closer than ever to solve this cosmic puzzle. Beyond its scientific intrigue, the corona plays a critical role in shaping space weather across the solar system. Solar flares and massive plasma eruptions, known as coronal mass ejections, originate in this mysterious layer, sending shock waves through space. Understanding the corona isn't just about solving solar mysteries, it's essential for protecting Earth's technology and future space missions. So the next time you gaze at the sun, remember it's not just a star. It's a celestial enigma with a crown of fire that both inspires and challenges our understanding of the universe. Neptune's supersonic winds. When it comes to extreme weather, Neptune takes the crown as the wildest planet in our solar system. Imagine winds so powerful they reach supersonic speeds of over 1,200 miles per hour, faster than the speed of sound. These are some of the most intense winds ever observed, making Neptune a chaotic weather powerhouse. The surprising part? Neptune is incredibly far from the sun, and its atmosphere should be freezing and calm. Instead, it's a stormy, dynamic world. Neptune's atmosphere, made mostly of hydrogen, helium, and methane, gets its beautiful deep blue color from the methane. But beneath that serene exterior lies an incredibly turbulent environment. The planet's winds are driven by a combination of internal heat and rapid rotation. Remarkably, Neptune generates more heat from its core than it receives from the sun. This heat rises and interacts with the atmosphere, creating conditions for the planet's astonishingly fast winds. Combine this with Neptune's quick 16-hour rotation, and you have a recipe for atmospheric chaos. One of Neptune's most famous weather phenomena is the Great Dark Spot, discovered by Voyager 2. This massive storm, comparable in size to Earth, had winds that reached extraordinary speeds. Although it disappeared after a few years, other storms have since emerged, keeping Neptune's atmosphere as unpredictable as ever. Scientists are still studying how these storms form and why Neptune's winds are so much faster than those on other planets. Neptune's violent winds aren't just a weather marvel, they're a scientific mystery. Understanding them can provide valuable insights into the atmospheres of other gas giants and even distant exoplanets. So the next time you see a picture of Neptune's calm, stunning blue, remember it's hiding some of the fastest and most chaotic winds in the solar system. Beneath its tranquil appearance lies a dynamic world of relentless storms and incredible speed. The Kuiper Belt's hidden worlds. Let's journey to the edge of the solar system, where the mysterious Kuiper Belt lies, a vast, icy expanse that's like the solar system's secret attic. This ring of icy debris, located beyond Neptune, stretches billions of miles and holds remnants from the solar system's formation. It's a cosmic time capsule filled with ancient hidden worlds waiting to be explored. While Pluto is the most famous resident, it's just one of thousands of fascinating objects in the Kuiper Belt. The Kuiper Belt is home to dwarf planets, comets, and countless icy bodies known as Kuiper Belt objects, or KBOs. Made of frozen gases, water, and rock, these objects are around 4.5 billion years old. Among them are dwarf planets like Pluto, Eris, Haumea, and Makemake, each with unique traits. Haumea, for instance, has a bizarre egg-like shape and rapid rotation. These icy bodies are like ancient relics, offering a glimpse into the solar system's early days. One of the most fascinating aspects of the Kuiper Belt is its role as a source of comets. When KBOs are knocked out of their orbits, they can travel toward the inner solar system, becoming comets with bright tails as they near the sun. These cosmic travelers offer clues about the raw materials that help build the planets, like postcards from the solar system's past. Despite its significance, the Kuiper Belt remains largely unexplored. NASA's New Horizons mission gave us the first close-up view of Pluto, and has since studied other KBOs like Arrokoth, a snowman-shaped object that has deepened our understanding of these distant worlds. This icy region challenges what we know about planetary formation and the outer solar system's dynamics. The Kuiper Belt isn't just the solar system's outer edge, it's a gateway to uncovering the history of our cosmic neighborhood and understanding our place in the universe. Who knows what secrets this icy frontier still holds? It's a reminder of how much there is left to discover beyond the familiar planets. The solar system's magnetic bubble. Let's dive into one of the most fascinating features of our solar system, the heliosphere. Picture a giant bubble stretching billions of miles, wrapping around all the planets, asteroids, and comets, shielding us from the harshness of interstellar space. This massive magnetic bubble, created by the sun, acts as the solar system's personal shield, constantly shaped by solar winds and cosmic forces. The heliosphere begins at the sun, where the solar wind, streams of charged particles traveling at millions of miles per hour, radiates outward, carrying the sun's magnetic field. As these particles travel, they form a boundary marking the edge of the sun's influence, known as the heliopause. Beyond this boundary lies interstellar space, filled with cosmic rays and interstellar winds. The heliosphere blocks much of this harmful radiation, creating conditions that make life on Earth possible. What's remarkable is how alive the heliosphere seems. The sun's 11-year activity cycle causes the heliosphere to expand during high solar wind output and contract during quieter periods, like a pulsating balloon. NASA's Voyager 1 and Voyager 2 spacecraft crossed the heliopause, providing groundbreaking data about this boundary and revealing what lies beyond. The heliosphere's significance extends far beyond shielding us from cosmic rays. It plays a key role in understanding how our solar system interacts with the galaxy and could impact space travel or even extraterrestrial life. The heliosphere isn't just a shield, it's a dynamic, evolving force connecting us to the universe at large and shaping the way we understand our place in space. And that's a wrap on the solar system's most unique features. From the violent winds of Neptune to the icy plumes of Enceladus, our cosmic neighborhood never ceases to amaze. If you enjoyed this journey through space, don't forget to like, share, and subscribe to InnoVision Tech. Hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.